All right, so I have a couple problems here. I think the goal should be I do a couple, and then you attempt the rest on your own. Ideally, then if you have any other questions about a problem, you can just ask me about it. So I think you'll find it's pretty simple once you do enough of them. It is something you're going to have to practice though, because it does show up just about everywhere. So what the overall goal of these problems is to write out our function, our equation, into its simplest form, to the point where we have whatever variable we have minus whatever, or our variable plus whatever, and then sometimes you'll see there's a GCF. So let's just kind of go through these. I think you'll pick up on it without much trouble. So we have a 4p and a 24. So in this scenario, we only have a p in one term, so we can't really do anything with that 24 or the 4p. So what we're going to do is we're going to check the numbers up front, and we'll notice that we can actually pull a number out of these, right? Because if we divide both by 4, and we take a 4 out, we would have 4. And then if we divide this term by 4, it would just be p. If we divide this term by 4, it would just be 6. Or negative 6. You got to pay attention to the sign too. So ultimately, your factored form, which is what it's asking you to do, is just 4p minus 6, right? So hopefully you can see how that's equivalent, because then if I were to distribute this 4, it would just give me the same thing I just did. So that one's kind of simple. Seems it ramps up a little bit, but it's not so bad. So again, here we only have one term with an a, or with just a variable, so we can't pull out any variable, but we can check for GCF. So in this case, the GCF is going to be 11. Since for finding that, I would just know your multiplication table. If you have access to a calculator, obviously that makes it a lot easier. If not, again, practice is really good for these sort of things. So if we pull out an 11, we're just going to do the same thing. So we're going to take 121 a squared divided by 11, and that's just 11 a squared. And then same thing with 44, we just minus 4. Again, keeping that sign. And that's our factored form. This is it. Maybe let's jump to, let's do this one. There's kind of three scenarios. Or, we've been over two, and here's like the, no, I'll say there's three scenarios. There's this one where we can pull out the variables too, and then the most common you'll see, which is like 5, 6, and 7. So let's do this one. So I kept talking about how we could pull a variable out of this one because both terms didn't have x. Well, in this case, both terms do have x. So we can start there. Okay, we can pull out at maximum 2 x's because the term with the smallest amount of variable is 9x squared. So we can take out 2 of those x's. So if we rewrite that, it would be x squared, 72x minus 9. See how we took out that x, but then again, it's equivalent because if we were to distribute that, it would be the same thing. So now we turn towards the GCF and we look at the numbers. In this case, it's just 9, so it'd be 9x squared, 8x minus 1. So hopefully that makes sense. Again, very important. It'd be the same thing for this one. I think though, I would try that one then. Maybe you do it on your own. You can pause the video, you can do whatever you want, but the final answer should be 41b to the fifth, 2 times b. So do what you will with that. All right, so while the first 4 problems are important, I think 5, 6, 7, and 8 are by far the most, they'll show the most, by far. So the way this is going to work is we're going to try to find a way how we're going to take this and split it into 2 equations. So because we have an x squared, we can rewrite this as having an x in both of these. Because if you were to distribute this, it would just be x times x, that's where we get the x squared. Now, where the main issue comes in is we need to have our 2 variables here and here. We need both of those to add to 2x and multiply to negative 48. So there's some methods for this, like completing the square. I'm not 100% sure how far you guys have gotten into that, or if there is a method you went over. If your teacher really wants to use a method, then you can tell me what the method is and I could teach you again, or you can kind of just do what I do. And what I think you'll find is also easier instead of doing the same equation over and over again is literally just guessing and checking, right? So I think the easiest place to start is how can we get 48? How can we multiply 48, right? So there's really only going to be 2 ways, right? If we did, or well, 3 ways. So 48 times 1, 24 times 2, and then 6 times 8. So again, we have to keep in mind we're trying to add to 2. So the only way that we're probably going to be able to do that is with our 6 and 8. Now, the signs also do matter because obviously if you added 6 and 8 and you had both those be positive, then we would get 14, and that's not what we want. So in this scenario, we're going to want plus 8 and minus 6. So now this would be our factored form. If you're having trouble seeing the equivalents, then you would FOIL this out. Hopefully you guys have covered that. But essentially it's you multiply the first 2 front terms, so that would be x squared. Then you multiply the front and the farthest, which would be negative 6x. Then you multiply the 2 in the middle, plus 8x. And then you take the 2 outside terms, negative 48. So if you simplify that, it would be x squared minus or plus 2x minus 48. So you'll see that they are equivalent. Really important. You'll get better at it with time. It'll show up everywhere though. So I think because this will keep showing up, these 3 can be practiced. If you want to check the solution, maybe you could text me. I don't know. Okay, we could do a word problem, I guess. Mr. Kim is testing his protocol. Mr. Kim's height, y, in feet above the ground after t seconds can be modeled by y equals negative 18t squared plus 24t. How many seconds is Mr. Kim in the air? Huh. Let me just think about this for a second. So we're given the function y equals negative 18t squared plus 24t. So the way we're going to do this is we're going to solve it just like one of these problems up here. And by doing that, we're going to set y equal to 0. Because if you think about it, he starts at 0, right? If he's jumping, he starts at y equals 0. He'll jump up to some other height. If he jumps a height h, he's at this height. And then again, he'll fall back down to y equals 0. So if we set it equal to 0, we're going to, and this is a function, right? So if you can model this height like, I don't know, say a parabola. Maybe it's too complex. Right, it is going to look like this though. You'll cover how to know what these graphs look like in higher level math courses, probably Algebra 2. But if this height function looks like this, there's going to be 2 times when its height equals 0. It's at the initial time and then at the end. We're looking for the end. So if we set y equal to 0, we'll be able to find what it is. So we set y equal to 0. We have negative 18t squared plus 24t. And now we're just going to treat it just like how we were doing it before. So we'll notice that they both have a t, so we can start there. So it'd be t times negative 18t plus 24. If we, I don't know if I said, but if we're taking, so if we have t squared and we're taking out a t, you just subtract the exponent. So it'd be like t minus 1, so it'd be just t. So now we'll look at this, but you'll notice 18 and 24 are good numbers because we can pull out a 6. So it'd be 6t negative 3t plus 4. So this is a good place to be because we set this equal to 0. So now that means with this t, we can solve both of these cases. We're going to treat these as two separate cases. We have this one, and then we have this second part. If we set both of those in their own instance together, you'll see then how we came up with this. So if we say 6t equals 0, and we solve for t equals 0, which is what I suggested would happen here, because initially, when he's about to jump, he's at a height of 0. So that makes sense that shows up. But then if we treat this one separately, 3t plus 4, and it equals 0, we solve for t. So we have 3t equals negative 4, t equals negative 4 over negative 3. These negatives will cancel, so you have 4 over 3. So this would be the second time that he's at 0. So it takes him 4 over 3 seconds. I don't know if it's right in decimal or fraction, but it should be 4 over 3. Again, you'll probably see a lot of similar problems to this, but most of the time it's just going to be, what's the second time he's done it, or, I guess maybe they could, if they told you what his max height was, you could set that equal to y and solve for t. So there's a couple other variations that you might see. For the most part, I think it's pretty simple. All these look pretty similar to what we were doing. I could do a couple of them, and then there's another word problem here. How much time are we at? 12 minutes. All right, we'll speed it up. We'll do like 2 of these. Okay. All right. So again, because we have b squared, we're gonna write this out as b something times b something. We want these to multiply to 7. So let's instantly think, how do we multiply to 7? I can only think of one, or one whole number, right? And it's 7 times 1. Thankfully, we want to add to 8. Oh. And 8's a great number because 7 and 1 are literally just 8. So you have a plus 7 and a plus 1. So our final answer would literally just be this. Maybe we can look at something more interesting case. Let's look at 25. This one will be really nice. So we're gonna write this out as b and b. Okay. So we want to multiply to 64. What ways can we multiply to 64? You probably think of a couple, but if you're struggling to think of answers, you can look at this too. Which you'll notice that this is really nice because 8 times 8 is just 64, and 8 plus 8 is just that. So you have this. Now, you could leave it as this. That is technically correct, but you can also write it as b plus 8 squared, which is equivalent to that. I don't know if your teacher would, make you write it as that, but that is technically how you do it. Okay, I feel like those are good practice for you then. Let's take a look at this. Okay, so now we got multiple variables, or at least in this one. I have to write prime if. All right, so I only just noticed that my recording stopped, and I did all this. So we're going to redo it real quick. So with these ones, also I don't understand what write prime if prime means. So if you could tell me what that means, we don't get it, that'd be great. But what we're gonna do is we're gonna treat these as two separate cases. We're gonna literally just block them off because we know these have a y and this have a y. So we're gonna put those together, and these only have x's, so we're just gonna put those together as well. Then we're gonna look at each separate case, and we're gonna take out what we can take out, and we can take out an x, and we can take out a y here. And you'll notice x plus 2 and x plus 2. That's great because we can treat those as their own separate thing and literally just pull out the entirety of x plus 2. So you're gonna have x plus 2 times x plus y is your final answer. 87, exact same thing. We see these have multiple t's, so we're gonna group those together. And in this case, there's not much we can do, so we're just gonna treat it as its own case, kind of leave it alone. We take out a t squared from this one because we only take out a t squared because that one's limiting, and you get t minus 1, t squared plus 1. For this word problem is fun. So I think it's important enough that I think it's important enough that I actually do the entire thing. So okay, or not. Okay, so you have the area of a rectangle. The area of a rectangle is length times width, and you're given a function of each of these. So all we're gonna do is we're gonna plug those in for a variable. So we have L equals 4 plus x, which we wrote here, and we have the width equals x, which we just wrote here. So, and we're given the area, which is 117. From there, we're going to distribute that x because we want this equation to look like a factorable function we've been working on up here. So once you rewrite that, you're left with x squared plus 4x minus 117. Not a fun number to factor, but again, if you have access to a calculator, it'd be a lot simpler. If you don't, kind of sucks. You gotta know your multiplication table, I guess. But in this case, it's going to be x plus 13 and x minus 9. And remember, we're going to treat these as their own separate thing. So we're going to have x plus 13 equals 0 and x minus 9 equals 0. So you're left with x equals negative 13 and x equals 9. Except we don't necessarily have to keep both because both are going to end up not being true. If you think about this rectangle in the real world, we can't have it be a negative number. There is no negative length. So we're going to throw this one out. We're going to say x minus negative 13 doesn't make sense. X equals 9 though? That does. So now that you have x, all you're going to do is plug in for these. So our width is just going to be 9 and our length would be 9 plus 4, so 13. And you can do a sanity check or, does that make sense by just simply multiplying the two. So you have 13 times 9. Well, that's 117. So there you go. That's exactly what we wanted. And that checks out. So if you have any more questions, let me know. I can go through them again or I can do more.